We're going to still talk about higher degree polynomials today, but focus more on the roots. We've talked about roots before, that the roots are the same as the zeros and the x-intercepts. Remember the x-intercepts? So we're not focusing on mins and maxes, just these x-intercepts. There are different types of zeros and roots depending on how they interact on the x-axis. If it does this bounce where it's coming down and then right back up, or it's coming up and right back down, that's called a double root. That counts twice. So when I identify the zeros of a function, I would say that, I think what's that at, -5, 2, 4, 5, I would say that x is equal to -5, but I know it's a double root and will count twice when I'm in my factored form of the equation. This other one is just slicing right through. When you cross right through the x-axis, then that x-intercept is a single root and only counts once. The third one is also crossing through just once. So I have a double with a bounce, a single with a cross through, and a single with a cross through. That means that these are the only zeros, 3 zeros, but if that's a double, I actually get a 4th degree polynomial. Now the 4th degree polynomial is also supported by the fact that my ends are going in the same direction here. Even degree, same. Odd degree, opposite. And since they're both pointed up, my a value is 1. So to write the factored form of this equation, putting it all together from what we've learned over the last few weeks, y is equal to positive a times x plus 5, and it's a double root squared, times x plus 2, single root, leave it alone, times x minus 1, single root, leave it alone. Well, let's look at this next one. For graph B, I have a double root, we're doing a bounce, a single root, cross through, single root, cross through. Notice they're at the same spots, -5, -2, and +1. So my zeros are still the same. They're still -5, double root again, -2, single root, 1, single root. And because double root, single, single together gives us 4 roots, then I have a 4th degree. However, this time, even though my end behaviors both pointed in the same direction, they're both pointed down. That means a is -1. So to write my equation, y is equal to -1 times my double root, x plus 5 squared, times my single root, x plus 2, times my single root, x minus 1. Let's talk about these other two. What kind of roots do we have? I have here a bounce, so that means it's a double. At -5, I have a double root. And here, I have a cross through. At -2, I have a single. And here, I have a bounce again. So I have, at +1, a double. These add up, double, single, double, to a 5th degree. And look, odd degree, opposite directions. Now, this last one is a little different. This is a cross through single root. This is a cross through single root. But do you see how this flattens out and then keeps going? It's almost like it was going to bounce, but decided, nope, I'm going to keep going. This is called a triple root. So my roots in this time, -5 is a single. It's crossing right through. At -2, I have a triple root. And then at +1, I have a single. So what degree polynomial would that make? Well, single plus triple plus single is a 5th degree, odd, and look at those ends, opposite, odd, so that makes sense. We also have to write equations based on the roots and finding that a value. And by a value, I mean that number that we have out front here. Positive 1 and negative 1 were what was given to us in the directions to just use positive 1 or negative 1. But there are times where we actually have to find a different number and calculate it algebraically. So we're going to look at this first graph together. First, analyze. I have opposite end behavior going down and up, so A is going to be positive. I have a single cross through, a single cross through, and a single cross through. So to start out my equation in my factored form, using my x-intercepts, I'll get to the y-intercept, but using those x-intercepts, then I have the equation y equals, I don't know a, times x plus 2.5 for my first root, times x minus 3.2 for my second root, times x minus 7.5 for my third root. Now I'm going to use that value here, 0 to 40. I'm going to put a 0 in for every x you see in this equation and 240 in for that y. I'm going to put 240 in the equation here and a 0 in for each of those x's. I want you to get your calculator out and just do this calculation. Put that whole thing in your calculator, and you get the number 60 when that happens. You get 60 for this times a, which is 60a, is equal to 240 that we put in for y. And if you divide, that means a is 4, which means my final equation is y equals 4 times, go back to your factors, x plus 2.5 times x minus 3.2 times x minus 7.5. And that is my overall equation.